I want to say hello to my mother that is in the hospital right now. She's watching me via YouTube. Uh, um, I have always been the performance girl. Um, Now I'm going to talk about the chaos. Um, I used to do negative performance testing. Um, and the first thing I learned is that chaos is not to break things. It's to prevent them from breaking. To prevent and to know how they're going to break. So if you have a functional environment, we work traditionally, and it came a time when we started using the cloud. We are now globalized. We do not provide service to a country only. We provide services to many countries in many languages. So the traditional approach was not enough. And then COVID came. If maybe you were about to release something, but then COVID, bam. The thing is, then I'll continue talking about COVID. Knowledge used to be in the hands of one person only. Oh, I don't know about this, but maybe it's one person only that knows about this. He is working on this project. He may know what is going wrong. And then we started working in microservices. So we need more superheroes. Now, there wasn't only one Superman. We have many Superman. So if we have a lot of microservices, we have lots of Superman. So we now have the Justice League of superheroes. But we may have a lot of microservices that we cannot fulfill. So we need to provide them with superpowers to make them work. We may face problems, avalanches, because one microservice might not be working, and we may not be as strong in the face of a problem. We may even create a service that we don't even control. For example, I may be a bank and my payment system is not working. So we have single point of failures. They may be a human mistake, because microservices are rather complex. And the problem may also be human or software related. The biggest system failures were like the Amazon or Facebook. All of them were caused by problems in configuration. or except one of them that was caused by a shark. Let's call it a shark. So most of them are caused to one person only. For example, if someone removed systems in the configuration without realizing that the load was rather high and millions of users were there at the moment, and everybody was stuck and everything fell like a waterfall. For example, monitoring may be green, but all of a sudden everything may be shut down. So we need to learn from these experiences. What we need to do is to learn from our mistakes. And this is how we create the villains. That may cause complexities, uncertainty. We may continuously fight these villains like circuit breakers, and that we may need to fight and mitigate. For example, cancellation dogs. But chaos sometimes may be caused by just us and us only. For example, due to configuration changes. So we are our own villains. We are the ones breaking the code. We turn into the Suicide Squad. We become antiheroes. And we need to learn what the villains do. And to fight a villain, we need to think as a villain. What's the difference between the superhero that does performance and the villain? The difference is that the performance wants to learn about the limits and the boundaries and extend the performance vision, because you are not looking only at performance. You want to make the system resilient and error-proof. So we try to create an order within the chaos. We want to know what is going to happen within the chaotic context of COVID. We may encounter an anomaly or unexpected load. So we want to find the failures and the problems and become superheroes. So we to allow us to find the problem before it strikes. So if I know that it's an anomaly, I know that there's a storm coming. So we introduce chaotic events in a controlled way. We are working in performance. We are in the environment that we want to. Production statements, staging, local. You may introduce chaos in a controlled way in the production stage. The other thing that you can do is while you are performance testing, you can monitoring in real time these events to simulate what will be happening in reality and to advance the different problems that may arise. You may check the metrics during the testing phase, the loading testing phase. You are, for example, doing stress testing, endurance testing, and you try to understand where the system may start breaking, and try to understand how the problems may be starting. What is happening to the system? What metric you can have to detect the anomaly that may end in an error. So you need to measure the impact. How did chaos start? That was a big explosion, and then dinosaurs appeared. Netflix that was already transitioning to a cloud. Introduced the revolution of understanding a new type of performance testing by injecting failures to the infrastructure. What may happen? For example, failures in hardware, in the switch, in the database access, many kinds of mistakes. These are not the public cloud providers. They defined the system under test, defined the normal behavior, and the starting hypothesis. So this is my scenario, my loading scenario in production. And then designed some kind of experiment for chaos testing. So they executed the experiment in the like making it fail for the database, and then analyzed the data, validating the hypothesis, and re-executing them. The hypothesis validation was to collect the data of production and bring them to the test environment and do it again, this time validating the hypothesis. So the superheroes of the Justice League get together and talk, discuss, create a theory, and draw benefits of the testing. Because if I don't draw any benefits from the test, why should I do the test? So the first thing is to build a hypothesis. I have an initial state. I want to get to a final state of stability, but in that period, I have some errors. I have insecurity. I create transition behavior because I'm going to create chaos. So I have the regular state, the regular state, and then you get to see what the impact was after you have introduced an anomaly. There are different things to take into account. We have small chaos that are easy to recover from. They are the most typical ones, but are the easiest ones. So there's not much to worry about. Then we have those that produce an availability problem. For example, you may have an outage in a microservice that I'm dealing with. So what happens in this case? What happens with this lack of availability? There's problems in your side, but it does not create a full outage because the system will be able to recover. And then you have those that are big and critical failures that are on your side. High chaos, for example, are the ones that have had produced a big mistake, a big error, which may be easy to find, but not so easy to recover from, because you need to have version compatibilities. So you may not find it as easy to make a rollback. And then you have the stream chaos case with errors that are very big but are not on your side. For example, a flood, things that are beyond your control. So what happens in the real world? If I say, oh, I'm using the cloud, so there's no problems. Everything is in the cloud. You may have some dude in Iowa in a data center. So you may be at ease because someone is behind there after like watching the cloud, but you may have to consider hardware failures. Then you have code errors. Our developers may cause software failures. We have events that are not of error, but provoked anomalies. For example, an anecdote. A friend typed instead of 1,000, he typed 1,000,000. So he didn't realize that when after making that mistake, he wasn't able to turn it back. And he had to recreate the whole infrastructure again. So that wasn't easy to recover from. So you need to take into account the dimension of the CPUs when configuring, among other things. Please raise your hands. How many of you have found configurations of your software that have come set from scratch? We are our own antiheroes. For example, I may see myself as the great aunt that knows everything about a product, but chaos may come, and then this may not be the case at all. So villains are the antiheroes. So we need a Superman. So we need help to achieve automation. At the beginning, nobody knew anything about microservices. So what we need is automation to keep things alive and constant through time. We need to treat complexities in a way that you analyze a problem part by part, and then you analyze a whole picture. This can be done in every layer, in every microservice, hardware, CPUs, disk. The metrics that we have are the same metrics that are in the cloud. You may have unlimited access if you have an unlimited credit card. So we may need someone that can see beyond what we have found. because we may not be prepared. So be ready for expect the unexpected, so to say. So roll back, roll back. So this is why automation may be helpful. You may roll back easily. Discover the unknown. For example, if I just for me, software is something that responds. And what happens if it does not respond? If the software does not respond, what am I to do? Sometimes this may be beyond my scope. For example, if I'm always experiencing a timeout, I need to discover what is going on, but this may be beyond my reach. When you introduce chaos, you need to reduce the downtime. You are exposed to the production errors and you are trained to be able to recover. This is not called the performance environment, but it is called training environment, which you face exposure to chaos environments. And where you constantly see pod failure. So, and to check if the red flag system has worked. So you get the training to be able to recover the system. The best practices to test is to have an action ratio, an action scope that is small. So don't run a test that outages the whole server from scratch. For example, great chaos, high chaos. The ones that are the most common are the low ones. So the action radius needs to be short. The tool, choose the one that is better suited for your test. If I need to introduce failure in an infrastructure, I may choose Gremlin, for example. If you have a chaos scenario, you may choose the one that is better suited. First, practice, introduce failures in a controlled environment. Remember that you'll be taking them to the production state at some point. Production needs to break. If you don't break it, you need to wait for someone to break it. Please measure the main time to recover. Train your teams to recover the system and to have it 100% available. Because if it breaks, they would take less to recover it if they're trained. And may take it to another region. Please be trained because we are always subject to failure. Men fail. Humans fail. So we need to have rollback. at our disposal to be able to get to the production environments. Because if something happens, users may not realize because you may have the tools to recover. Most tools are open source, Litmus and Gremlin. Depending on your needs, the one you will choose. In this case, I'm using Cowsmet because I'm using the preview version of this tool. The infrastructure is in Azure, which allows me to have a central dashboard to control Kubernetes and clusters and the chaos experiments. And I control all of it. I may do something else. For example, injecting another tool to the Kubernetes, but I wouldn't have everything centralized. Why am I using the one that I'm using if you can use whatever? The important thing is observability. You need the full vision. So this tool needs to centralize your system of experiments. So this is why I choose the tool that I'm using. So I'm running out of time. So this is the code. And you will be able to see it if Fede invites me to deliver the workshop. Thank you.